For a burn pit ignition system transmitting 20 kilovolts over 150 meters, specialized high-voltage wires are essential. Ordinary wires are unsuitable. High-voltage cables designed for high voltage levels, typically 20 kilovolts or higher, are needed. These cables use insulation materials such as cross-linked polyethylene, abbreviated XLPE, or ethylene propylene rubber, abbreviated EPR. For thermocouple wires, use type K thermocouple wires like RG36 or AWG30 constructed from high-temperature resistant materials such as chrome and aluminum. For the 20 kV phase wire, select insulated copper wire rated for 20 kV or higher, such as AWG10 or AWG8, ensuring the conductor cross-sectional area matches the current requirements. For the null wire, utilize unshielded copper wire rated for at least 1 kV, such as AWG14 or AWG12, serving as a reference voltage for the ignition panel. Several additional factors are important. Firstly, distance. The voltage drop across the 150-meter distance must influence the selection of wire gauge and insulation thickness. Secondly, safety. Ensure all wires are well insulated, shielded, and protected from environmental factors to prevent electrical hazards. Thirdly, certification. Use wires certified by respected standards organizations such as Underwriters Laboratories, abbreviated UL, or the International Electrotechnical Commission, abbreviated IEC. Selecting the appropriate wire gauge involves calculating the voltage drop over the 150-meter distance. The voltage drop is influenced by the wire's resistance, which is determined by its material, length, and cross-sectional area. Using a thicker gauge wire reduces resistance, minimizing voltage drop. The formula for voltage drop is voltage drop equals current multiplied by resistance. To maintain adequate voltage at the ignition point, the voltage drop should be within acceptable limits, typically less than 5%. The current carrying capacity, also known as ampacity, of the selected wire must exceed the maximum current expected in the circuit. The National Electrical Code, abbreviated NEC, provides tables such as Table 310.15b16 that list the ampacity of various wire gauges based on their insulation type and temperature rating. It is essential to consider the ambient temperature and air the ampacity accordingly to prevent overheating and potential insulation failure. The insulation material plays a crucial role in high-voltage applications. Cross-linked polyethylene, abbreviated XLPE, and ethylene propylene rubber, abbreviated EPR, are common choices due to their high dielectric strength, heat resistance, and moisture resistance. Dielectric strength refers to the ability of the insulation to withstand high voltages without breaking down. The insulation thickness should be sufficient to prevent arcing or breakdown, especially at 20 kilovolts. Selecting the right insulation material ensures long-term reliability and safety of the ignition system. Shielding is necessary to prevent electromagnetic interference, abbreviated EMI, and to contain the high voltage field within the cable. Shielded cables typically have a layer of conductive material, such as copper tape or braid, surrounding the insulation. This shield is grounded to provide a path for stray currents and to minimize electrical noise. Shielding is particularly important when running high-voltage cables near sensitive electronic equipment or in areas with high levels of electromagnetic interference. Proper grounding of the shield is crucial for its effectiveness. Environmental factors such as temperature, moisture, and exposure to chemicals can significantly impact the performance and lifespan of the wires. High-temperature environments require wires with high-temperature insulation ratings. Moisture can degrade insulation and lead to corrosion, so moisture-resistant cables are essential in damp or wet locations. Chemical exposure can also damage insulation, so chemical-resistant cables should be used in areas where chemicals are present. Protecting the wires from the elements with conduit or other protective measures is highly recommended. Proper installation is crucial to ensure the safety and reliability of the high-voltage ignition system. This includes using appropriate connectors, terminations, and grounding techniques. High-voltage connectors should be rated for the voltage and current levels of the circuit. Terminations should be properly made to prevent loose connections, which can cause arcing and overheating. Grounding should be done in accordance with the National Electrical Code, abbreviated NEC, and local electrical codes. Testing and commissioning are important steps to verify the proper operation of the ignition system. This includes performing high potential testing, also known as HIPOT testing, to verify the integrity of the insulation. Continuity testing should also be performed to ensure that all connections are properly made. Regular maintenance and inspection are essential to ensure the long-term reliability of the ignition system. This includes visually inspecting the wires and connections for signs of damage or deterioration. Insulation resistance testing should be performed periodically to monitor the condition of the insulation. Any damaged or worn wires should be replaced immediately. The thermocouple wires, typically Type K, are used to measure the temperature within the burn pit. Type K thermocouples are made from chromal and aluminum, which are nickel-based alloys known for their high temperature stability and resistance to corrosion. These wires generate a small voltage proportional to the temperature difference between the hot junction and the cold junction. The voltage signal is then sent to the ignition panel, where it is processed to display the temperature. The selection of thermocouple wire gauge depends on the distance and the desired accuracy. Thicker gauge wires have lower resistance, reducing voltage drop and improving accuracy. However, thicker wires are also less flexible and more expensive. The reference voltage provided by the null wire is used by the ignition panel to accurately measure the thermocouple voltage. This wire should be shielded to minimize electrical noise and interference. The null wire should be connected to a stable ground reference to ensure accurate temperature readings. The ignition panel typically includes signal conditioning circuitry to amplify and filter the thermocouple voltage signal. This circuitry compensates for errors caused by ambient temperature variations and other factors. The ignition panel also provides safety interlocks to prevent the ignition system from operating under unsafe conditions. These interlocks may include over-temperature protection, low-voltage protection, and flame detection. The entire system, including the wires, connectors, and ignition panel, should be designed and installed in accordance with the National Electrical Code, abbreviated NEC, and other applicable standards. High-voltage systems pose significant safety hazards, and it is essential to take all necessary precautions to prevent electrical shock and fire. Only qualified personnel should work on high-voltage equipment. The Underwriters Laboratories, abbreviated UL, and the International Electrotechnical Commission, abbreviated IC, provide standards for the safety and performance of electrical equipment. Using UL-listed or IEC-certified wires and components ensures that they have been tested and found to meet stringent safety requirements. These certifications provide assurance that the equipment is safe to use and will perform reliably. Proper documentation is essential for the maintenance and troubleshooting of the ignition system. This includes wiring diagrams, equipment specifications, and maintenance records. The documentation should be kept in a safe and accessible location. Regular training should be provided to personnel who operate and maintain the ignition system. This training should cover safety procedures, troubleshooting techniques, and maintenance requirements. Properly trained personnel are more likely to identify and correct problems before they lead to equipment failure or safety hazards. The long distance of 150 meters introduces several challenges that must be addressed in the design and installation of the ignition system. The voltage drop over this distance can be significant, especially with high current loads. This can result in reduced performance and potential equipment damage. To minimize voltage drop, it is essential to use appropriately sized wires and to minimize the length of the wiring runs. The use of step-up transformers can also help to compensate for voltage drop. Electromagnetic interference, abbreviated EMI, can also be a problem over long distances. This can be caused by nearby electrical equipment, radio transmitters, or other sources of electromagnetic radiation. Shielded cables and proper grounding techniques can help to minimize electromagnetic interference. Surge protection is also important to protect the ignition system from voltage surges caused by lightning or other electrical disturbances. Surge protective devices, abbreviated SPD, should be installed at the service entrance and other critical locations in the system. These devices divert excess voltage to ground, protecting the equipment from damage. Regular inspections and testing are essential to ensure the continued safe and reliable operation of the ignition system. These inspections should include visual checks of the wiring, connections, and equipment. Insulation resistance testing should be performed periodically to monitor the condition of the insulation. Any damaged or worn component should be replaced immediately. By following these guidelines, it is possible to design and install a safe and reliable high-voltage ignition system for a burn pit, even over a long distance. Remember that safety should always be the top priority, and only qualified personnel should work on high-voltage equipment. Utilizing appropriate wire types, insulation, shielding, and grounding techniques are critical for preventing electrical hazards and ensuring reliable performance. Consider using conduits or other protective measures to safeguard the wires from environmental factors and physical damage. Adherence to the National Electrical Code, abbreviated NEC, and other applicable standards is mandatory for ensuring compliance and safety. Proper documentation and training are essential for the long-term maintenance and troubleshooting of the system. Regular inspections and testing should be conducted to identify and address any potential problems before they escalate into major issues. High-voltage cables rated for 20 kilovolts or higher are specifically designed to handle high voltage levels and are insulated with materials such as cross-linked polyethylene, abbreviated XLPE, or ethylene propylene rubber, abbreviated EPR. Type K thermocouple wires, such as RG36 or AWG30, are made from high-temperature resistant materials like chromelin aluminum. Insulated copper wire rated for 20 kilovolts or higher, such as AWG10 or AWG8, should be used as the 20 kilovolt phase wire with an appropriate conductor cross-sectional area to handle the current. Unshielded copper wire rated for at least 1 kilovolt, such as AWG14 or AWG12, should be used as the null wire, serving as a reference voltage for the ignition panel. The voltage drop over the 150-meter distance must be taken into account when selecting the appropriate wire gauge and insulation thickness. All wires must be properly insulated, shielded, and protected from the elements to prevent electrical hazards. Use wires that are certified by reputable standards organizations such as the Underwriters Laboratories, abbreviated UL, or the International Electrotechnical Commission, abbreviated IEC.